Hello everyone. In this session, we'll be running all the different types of load multiple and store multiple instructions and see how exactly it works. Okay. So the very first instruction we have is LDR R0 comma equal to value. Okay. So let's see what exactly is the address marked by this particular label. It is 4000. This particular address initially has value 0. Okay. Now what we are doing is we are loading register R1, R2, R3, R4, that is these registers with these 32-bit values. Let's do that. So next what we have here is STMIA R0, R1 to R4. Okay, so here our base register is R0. Let's see what R0 has. So this is the initial address we are considering. We want to store whatever content is there in register R1, R2, R3, R4. What is it? These values into this particular memory location. And we don't want to update the address of R0. So R0 remains as 4000 even after this instruction is executed. Okay. Now, how exactly values should be updated here? So if you notice here, we have register R1, R2, R3 and R4. Each register has 32-bit data. So to store their content in memory, we need 4 locations. Okay. But the question is, which particular register content will be stored in the first location? And the answer for that is R1 in this particular case. Why is that so? Because we are storing from lower memory address to higher memory address. So the lowest memory address should be filled with lower suffix. Okay, and that goes on continuing. And now how will 1 2 3 4 5 6 7 8 be placed here? It will be placed order 7 8 5 6 3 4 and 1 2. This is because of Little Indian system. Okay, so let's see that happening, and along with that what happens to next locations? R2 will be placed here, then it will be R3, then it will be R4. And what happens to your content of R0? It is unchanged. So let's see that happening. As you can see here, R1 content is in this particular location, R2 is in this location, R3 is in this location and R4 is in this location. And if you check R0, it remains unchanged. Okay, so next instruction is exactly same. I have just changed one thing. I have added an exclamatory mark. Let's see how that affects the entire content. If you notice, R0 is now updated. This location will start at 4000. So this will be 4004. This will be 4008. This will be 4000C and this will be 4010. Okay, so this is the location pointed by R0. Okay, why is that so? Because it's increment after. Okay, now what should happen? Our initial address of R0, when you consider the next instruction, will be nothing but this particular location only. Okay, but it is decrement before. What does it mean? First decrement the address so that it points at this particular location, then start loading this value into the registers specified here, that is R5, R6, R7, R8. Let me write it. So we have register R5, R6, R7, R8. Very first thing you should remember is higher memory address, whatever data is there, should be placed in register with higher suffix. This is how the placement will happen. Okay, but we will see that it will be arranged in the opposite order, that is instead of 7 8 5 6 3 4 1 2, it will be 1 2 3 4 5 6 7 8 because of our Little Indian system. Okay, let's see that happening. Now initially all these registers are 0. So what we noticed here is 4444, that is this content is now loaded to R8 as expected. This content is in R7, this content in R6 and this content in R5. And one more thing if you notice here is we decrement before loading. Okay, so first decrement happened here, next here, next here, next here. So this itself was the address being held in the register ARM. Next what we have is, we are trying to store the data here from register R1, R3, R4. We have ignored the content of R2. What is R1? It is this is R3 and this is R4. Okay, now what we have is nothing but we want to store, but our concept here is increment before. What do you mean by increment before? Now this is your initial address, that is nothing but 4000. We want to increment to this location. What will be the address? From this location we start storing the data, that is this will get the content of register R1, this will get the content of register R3, and this will get the content of register R4. Let's see how that changes the values here. And one more thing, we have R0 followed by an exclamatory mark, because of which what happens to address in R0? So it was initially here 4 and all zeros, so the final value will be the address of this particular location, okay, which is nothing but 4, all zeros and C. Let's see that happening. Okay, so this particular address is uploaded here, and now if you notice, R1 content, which is 1 2 3 4 5 6 7 8, is placed here in the reverse order as expected, and then R3 is nothing but 3 3, so it's placed here, and R4 content is also updated. Okay, so what should happen in this particular case? We are loading the data from this particular location and placing it in register R5, R7, R8. You can see that R5 was 1 2 3 4 5 6 7 8, R6 was 1 1 1 1, R7 was 3 3 3 3, and R8 was 4 4 4 4. We know that the lower memory address, whatever content is there, that should be placed in R5. This will be placed in R7, this will be placed in R8. This we already know. But what exactly is happening here? So here we have decrement after. So initial location where R0 is focusing is this location, that is pointing at this particular data. So because it's decrement after, the very first data here will be placed in R8. This data will be placed in R7, this will be in R5, but what happens to the address which is there here? Because it's decrement after, this address, that is this one, will be now stored in R0. So one thing you'll notice here is, except for R0 register address, any other content won't get modified. As you can expect from this instruction, only R0 got modified because same values were present previously in R5, R7, R8, and the newly uploaded data are also same. Okay, so next what we are trying to do is nothing but we are trying to store, okay, but using instruction decrement after. Okay, so as per this particular instruction, what we can notice is nothing but we are trying to store the data present in register R1 and R4. Okay, so we have two registers here. This register, if you consider the suffix, is higher. Okay, so this will be placed in higher memory address, this will be placed in lower memory address. Now we have to see which memory address are we speaking about. Here the initial address is given by R0, which is 4000. 4000 is this particular location. Okay, but it is decrement after, so it means first store the data R4, whatever content is there, place it in this particular memory location, then decrement it and place this particular content in this particular location. See that happening. Okay, so as you can expect, R4 content, which was all 4s, is now placed here, and R1 content is now placed here. But one more thing you noticed is R0 address is updated in this way. Why is that the case? Because it was decrement after. So first address was this one. Okay, so in that location only we added some content, then we decremented, we added the content. So what will be the address of R0? It will be pointing at this particular location. Next instruction is nothing but increment before. What does it mean? Initial address is this location, increment it so that it points at this particular location, load this particular data into register R6, and then increment it next, load this into register R7. See, it's written R7 R6, but I have written this way because lower memory address, whatever content is there, will be placed in register with lower suffix. Okay, this will be placed in R7. And what happens to R0? This address, which is your 4000 only, will be now placed in the register R0. Yes, this is correct. And what happened here? This value was loaded into R6 and this was loaded into R7. So the category of store we are discussing is decrement before. Okay, so what is R0 content? 4000. So this is our initial address of R0. Okay, what they want to do, decrement before. So you have to go to lower memory address. Let me consider something like, we already know these are the 4 registers getting discussed here. Okay, this has the highest suffix. Okay, so the first highest memory location will be stored with this particular content or this register content. So which location are we speaking about? See, 4000 is the initial location, but it is decrement before, that is decrement before storing. So first location will be this, where R4 is loaded. Here it will be R3, here it will be R2, and this will be R1. Okay, but because it is decrement before, okay, the address of this, that is nothing but 3, all F's and 0 will be stored in the register R0. Okay, let's see that happening. Okay, so if you notice here, 3 all F0s is now the new value of R0. At the same time, R4 content was nothing but 4s, R3 content is all 3, R2 content is all 1, and R1 content is 1, 2, 3, 4, 5, 6, 7, 8. So that is placed in the specified locations. And the very last thing pending now is loading. Okay, we are loading multiple data into the register R5, R6, R7, R8, okay, from this particular location. So how exactly are we doing that? We should consider the initial address. So it's increment after. It means initial address is 3F, all F's and 0. From this location, start loading data into the registers. We have register 5, R6, R7, R8. Which of this register should get the very first value? That will be R5, because we are moving to higher memory addresses. What happens to this data? It is moved to R6, this will be moved to R7, and this will be moved to R8. But what happens to your address in R0? If you notice here, this is the initial R0 address. Because it's increment after, so after loading the final data, this is the address which should be loaded into the register R0. So what exactly is that address? 4000 is the address. Let's see that happening. Okay, so 4000 address got updated here, and along with that, what is R5? R5 is 1, 2, 3, 4, 5, 6, 7, 8. R6 is 1 ones. R7 is all 3, and R8 is now loaded with 4, 4. Okay, so these were few things you needed to know. Okay.